Assalamualaikum warahmatullahi wabarakatuh. So for the experiment 1, which is Marcet boiler, so the introduction for this experiment, we got objective and also scope. And then for the objective, to observe the relationship between the pressure and the temperature for saturated steam. And then for the scope, when the temperature is 97 degree to 100 degree, the overflow valve was closed. And then the increase and decrease of the temperature is recorded for every 0.5 bars, starting from 0.5 bars to 5 bars.
For the theory, thermodynamic properties of a pure substance could be determined by two of the following characteristics: T, P, H, S, V, and etc. Data characteristics could be obtained either from experiments or equations, or using certain. Among two thermodynamic properties that easily measure are T and P, which is the temperature and pressure. Relations between these properties could be expressed in the form of graphs or equations. Clapeyron equation is as follows. In the equation given, when Vf is the volume of water, Vg is volume of steam, Hf is enthalpy of water, Hg is enthalpy of steam, and Hfg is equal to Hf minus Hg, which is the heat dormant of vaporization. Dormant for the heat value of water can be obtained from the equation. For this experiment, we will be using the Marcet boiler, which can be seen in the diagram. The components are as labeled from number 1 to 11, which are the drain valve, heater, overflow valve, filler plug, safety valve, temperature sensor, manometer, boiler with insulating jacket, temperature gauge, heater switch, and master switch.
So for the methodology, as already explained by Brian about the apparatus, about the location of any part at the Marcet boiler. So now I will explain about how to conduct this experiment, which is methodology. So for the first step is water was filled into the boiler by opening the filler plug, and then the overflow valve is made sure open and the water was let to flow out from there when the boiler is full, and then the filler plug was closed back. So the water in the boiler was heated with the overflow valve open. And the third one is when the temperature reached about 97 degree to 100 degree, the overflow valve was closed. The increase in temperature was recorded for each pressure increment of 0.5 bar until the pressure reached 5 bar. So basically the pressure we can read from the manometer from 0.5 bar, and then we take the temperature. After that, 1 bar we take the temperature, 1.5 bar we take the temperature until 5 bars. And then the heating was switched on and the decrease in the temperature for each pressure of 0.5 bar was recorded. So basically after we take temperature from 0.5 bar until to 5 bars, we will switch off the heating, and then we take the temperature from 5 to 0.5, which means that the temperature when 5 bars, and then we take the temperature after we switch off, we take the temperature for 4.5 bars until 0.5 bar. So the increment and decrement. Okay, so lastly the result obtained are recorded in the table. That's all.
Okay, so from the results, we can see that as the absolute pressure increases, the steam temperature will also increase, and the measured slope will slowly and over time decrease, which is interesting, but it actually relates to our Clapeyron equation, which states that the difference at the rise and run of the temperature and pressure will over time decrease, aka the slope lah. The slope will over time decrease as we reach higher and higher temperature and pressure. And we can also observe that our calculated slope from the experiment also decreases, although the value are um, lower from what we get from the experiment. Okay, as you can see in this the graph, the slope gradually smooths over and gradually gets better as we reaches higher and higher pressures and temperatures. So, for our discussion, we can observe that as the boiler heats the water, the pressure and temperature inside the boiler will keep increasing. This is because when the temperature increases, the steam will gain more kinetic energy and vibrate more excitedly, which increases the collision between the particles and the inner boiler wall, which in turn increases the pressure inside the boiler. This can be shown using the ideal gas law, PV equals to nRT, which assuming the steam is nearly ideal with the volume of water, in the volume of boiler, the number of moles of water inside the boiler, and the gas constant R, Marcet constant, the pressure is directly proportional to the temperature. Therefore, as the temperature increases, the pressure will increase. Okay, for the next part, according to the Clapeyron equation, the pressure is inversely proportional to the value of T multiplied by the difference of volume of gas and fluid divided by the by HF minus Hg. Since in the boiler, the water in liquid phase is completely boiled to steam, therefore the value of Vf is neglected, and therefore we can conclude that the value of T multiplied by the volume of gas divided by HF minus Hg is inversely proportional to the pressure.
For safety procedure, first wear appropriate PPE, including safety goggles, gloves, and heat-resistant clothing. Next, use insulated gloves or mitts when handling hot equipment to prevent burns, and inspect for any visible sign of damage, corrosion, or wear before using the equipment. Maintain a safe distance from the boiler during operation to avoid exposure to high temperature or pressure-related hazards. And lastly, clean up spills promptly to prevent slip and falls. Mm, Lastly, conclusion. Our experiment shows nonlinear trend similar to Clausius-Clapeyron equation. Clausius-Clapeyron equation describe real gas behavior, explaining the pressure and temperature relationship between two phases accurately. Clapeyron equation limitation is assumes ideal gas behavior. This will leading to increased errors at high temperature and gaseous more accurate below the boiling point of the substance. Next, human error. It result can be impacted by human error such as parallax and measurement inaccuracies. And conclusion, for better accuracy, use the Clausius-Clapeyron equation, especially at temperature close to or above the boiling point of the substance.